Yes, you can start the recording. Because I have already discussed about the differences between the power electronics and linear electronics, right? In the last class. You have to interact with me. Some of you must open your, unmute your mic. Okay? Hello.
Yes, sir.
So you have to interact with me, otherwise it will be very difficult. Now, so I am doing formally some of the things from your Ned Mohan books. The first 30 topics, I think you are can see it. 1.2. Sometimes I give some examples in the questions, or sometimes I also put some problems from the chapter. So I feel I need to discuss this thing. So in power electronics, you have to now tell me, we have two types of electronics here. Because one is the linear electronics, another is the power electronics, right? In the last class, I have told you what are the difference between the linear electronics and power electronics, or what are the advantages of power electronics over linear electronics. Did I do that? Did I list it? Hello.
Yes, sir.
So now, today I am giving you some examples from the book. If you look at the figure, this is the code is the power, regulated power supply, or you will get a constant voltage here on the load. Constant DC voltage. If we want to get constant DC voltage, we can use any rectifier, and then if the input voltage does not change, then of course you will get that constant DC voltage. But the thing is that if you want to get the variable voltage here, variable DC voltage, then the primitive way to do that, you can use a voltage divider circuit like this. Suppose this is your 100 volt. This is your 100K, this is your 100K. If this is your O, what will be your output?
50 volts.
50 volt voltage divider, right? That is, but the thing is that if you apply this kind of voltage divider by using a potentiometer here, changing the resistance, then you will get a variable voltage here. But there will be loss, power loss in the resistance here. So it will not be effective. So in the linear electronics, I don't know whether I have given this example to you. You remember that some this is a BJT circuit. We look like this. So if this is your VCE, this is your say C, and this is your P, this is your P. What C stands for?
Collector.
And E
Emitter.
and B.
Base.
Base.
So if you now say IC current is here, if we now on the plot for different head of IB, can you remember that we got this kind of thing? I taught you.
Yes, sir.
Okay, so here if the IB equal to 0, So we will be here. And for different value of the IV, we will get different curves by changing the value of this. We suppose we have a circuit here. Now, for a particular value of say, this is your saturation region. When IV equal to 0, we call it here in the compass. And here this is the saturation. What is the voltage of VCE here? What will be the voltage? Saturation voltage is
0.3.
So minus 0. Oh, sorry, 0.3.
0.3, and this can be taken as ideally you can take it as 0. So that means if we operate the transistor in the saturation mode, the voltage is what this is a short circuit. And if we make it IV equal to 0, then it will be operated. So then we call it we are operating a transistor, the switch. But if you operate your transistor in the active mode, here, I am repeating the figure here. And we are using this portion will fluctuate all time. So the relation between voltage and current, if it is linear, so what will be the V by C by say IC? Particular value. What you will get? Voltage by current.
Resistance.
Right. So this is ohms. So that is why they have shown it. This is the resistance here. We will operate our transistor in the active mode. Now, if we move for a different value of I, suppose we are going here. If it is these are not parallel, rather than we will get different value of resistance. Then with that different value of I, then we will have a variable resistance. If we have a variable resistance, then we will get a variable output voltage. You got it or not? Any question? So what we did here from the utility, can you see it from the utility? Utility means the power supplier or the power provider, electric power provider like PDB, REB in Bangladesh. So we have used a transformer here. The function of the transformer is to step up or step down the voltage. So they mentioned here that this is the line frequency transformer. So if the frequency, line frequency means what is our line frequency at our home or in our system?
50 hertz.
50, right, 50 hertz. So this is very low frequency compared to say 200 hertz, 300 kilohertz, 200 kilohertz, right? 50 hertz is small. And in the transformer, I think you have already studied in second year, although you're online, I don't know how much you have learned. The core area of the transformer is inversely proportional to the frequency. So that if the frequency is very small, then the core area would be large. Okay. If you can increase somehow the frequency, then your core area will be smaller. Then you can use smaller size of transformer. So if you use this kind of regulated, sorry, not regulated, DC power supply, variable DC power supply. If you want to use it in the linear electronics, that means in the say active mode of operation, then we have a variable resistance we can achieve, and this resistance will absorb the power. So there will be heat loss, efficiency will be low, and we need a very big transformer to step down the voltage here, and then peak transformer means transformer cost will be high, and also the system will be bulky. Okay. Another thing is that if the frequency is low, this is the filter capacitance, the capacitance will be very high. It is becoming bulky. So did I list out the difference between the power electronics and linear electronics in the last class?
Yes, sir.
So here the example is that if we use this linear electronics, then we have bulky transformer, expensive, and also there will be loss here, and it will be less efficiency, and we are operating in the linear lens difference. Advantage wise, it is not good for high power. Okay. So now then, what will be our alternative? We must go to the. Okay. There is a figure here. So can you see the figure?
Yes, sir.
So if you know that we have used the simple circuit here. So if the utility has a magnitude variation for any reason, you know the voltage fluctuates. If it fluctuates, then the output will be this VD will be, you know, what will be the expression of this VD? If you are using a full diode rectifier, can anyone tell me what will be the value of the expression of the VD? Hello? 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 What will be the expression of the VD? Nobody can answer it from section B. So we have here, say, here. So we have 5 PM sine of omega t. Here. In the secondary of your transformer, we have PM sine of omega t. What will be the DC value here? Of course, we will get here something like that. Then we make it by using this capacitor, we get a DC value. What will be this value? Can anyone tell me? With respect to PM, you are using full rectifier. Can you see me?
Yes.
In the side.
পোলাপাইন একটু ওয়েট কর, স্যারের সাথে কথা হয়েছে, স্যারের হচ্ছে জুম প্যারা দিতেছে, আসবে 5 মিনিটের ভিতরে।
ওকে বস।
কি ক্লাস করতেছিস?
Hello.
Yes, sir.
আমাদের Zoom ঝামেলা করতেছে। আমাদের Zoom রিপিটেড সরকারি একটা আছে। দেখা যাচ্ছে? হ্যালো,
জি স্যার।
জুম ঝামেলা করতেছে। এটা এখন আমার তো ইন্টারনেটে হটস্পট দিয়ে আমি চেক করলাম, যায় না। হচ্ছে দেখো, আমি যা বলছিলাম, what I was talking about, so where I was, okay, I'm talking about, okay, it's talking about if the voltage is varied, like here, suppose this is your supply voltage, and this is your say the primary voltage, and this is the secondary voltage Vs, and this Vs equal to Vm sin of omega t. Then I'm asking you what will be the the average value of this one, Vdc. What will be the expression of this one? Can anyone tell me what will be the expression for the Fourier rectifier? This is the rectifier, uncontrolled rectifier. Uncontrolled rectifier means we are using the diode. Then it will be, you forgot, 2 Vm by pi. Can you remember this? Hello?
Yes, sir.
Yes, sir.
So this Vm is the peak value. So if it changes 10%, so look here, your VDC or VD will be changes. So if it contains the, say, some ripple, so you will get not exactly the AC voltage, sorry, DC voltage. So you will get a voltage like this. Before the here, actually here. And after, if you use, and then it will change, it may change 10% if the Vm changes 10%. So this value ddt, they call it with respect to time. But if you use a very large capacitor here, then you will get a voltage, a DC voltage, we call it DC voltage you will get after filtering, and that voltage, the expression of that voltage will be this one. So here we see that if the voltage changes, then we will get a range like this. Okay, and can anyone tell me suppose I want a voltage here 100 volt. From here to here, like from here to here, I want 100 volt. So here this VDC or VD, this one, it should be less than, equal to, or greater than 100 volt.
It should be greater than 100.
Right. So that means that this voltage should be greater than, of course, the voltage what you want, and then because you are using a voltage divider circuit, right? Okay. So you have to then manipulate this way your thing, otherwise you will not get it. So that has been given here. So this is your output voltage V0, that is the DC voltage. And if you integrate it over one cycle and divide it by the time period, you will get the average. So that it is mentioned here. If you read it, the ratio of the transformer must such that the minimum voltage VT is greater than the desired output voltage. And also, if you use the line frequency transformer, it is very large, and also the power loss will be there. But in power electronics, now we will be talking about our power electronics. If you want to use our power electronics here, so let us look at a circuit. So what will be the probable circuit we can design? Okay, this is not, you should not go very depth, just rather than just we're trying to show how the power electronics is better than linear electronics. So look here from the utility here. From the utility. Utility means power supply provider. So they are supplying a voltage of at 5 hertz frequency, and this voltage will be the cell. If it is line to neutral, that means single phase, is 230 volt. Or sometimes 235 volt. It varies from 220 to 235 volt. So look here, have we used, did you use any transformer here? Hello?
No, sir.
No, sir.
No, so you don't need any transformer, just you use the rectifier directly, and then you get a rectified voltage, and that will be like this. So this is the PDT. And then in the input side, here in the input side, what we have designed a circuit like this. So there is a winding here, and there is a dot, and in the upper side dot. That means when the voltage is positive, then you will get it. Of course, here you will get always a positive voltage. And what you will do, there will be switching device. What is the switching device we are using here? BJT. And that switching is controlled by your, say, VV voltage. And that VV voltage is nothing but the control voltage. Of course, this is the control signal. Control. I have already discussed these things in your first class, previous class. This control signal will control what will be the, what type of signal we will give to your base, so that you can change the frequency, you can change the magnitude, whatever. Mainly not the magnitude, rather than the switching time. So you can make like this. You can make the, so suppose this is your switching voltage V. So up to this period, it is turned on, T on, and this is your T off. And you are already familiar with this one, right? TS, we call it the switching time period, and that must be equal to T on plus T off, and that must be equal to 1 by Fs. Are you familiar with this one? And then there is a D, and people call sometimes K, we call it duty cycle. Duty cycle. So that is nothing but T1 by Ts. So are you familiar? Do you know this?
Yes, sir.
Yes,
Yes, sir.
sir.
Your science sir should have already given you the idea of the duty cycle, right?
Yes,
Yes
sir.
or not? Okay. So now what we do, we switch on. If we switch on this one, the current will flow this way, this way, this way, and it will back this way. And then if we make it off, then this circuit will not be there, and then the this diode will be turned on, then the current will go this way. So then we will get a AC like signal here, but with a very high frequency. Who will determine? Can anyone tell me who will determine this frequency? What will be
So
the
the
frequency
controller.
of this? Hmm?
The controller.
Right. This is the controller. So in this book, it is mentioned that this switching frequency could be 300 kilohertz. It depends on the device what you are using. Okay. So DZT may not be available with this 300 kilohertz frequency. Maybe you may use MOSFET or you may use IGBT whose frequency is high. But again, the switching loss, the loss in your switch is directly proportional to your the switching frequency. You have to consider that one. So if you increase too much, okay, you are using a high frequency transformer here. So if you increase the frequency of your AC signal here, it is not that, it is AC alternating, but not sinusoidal. So you can increase the frequency, but and then your high frequency transformer core will be light. This is good, and the cost of the transformer will be less. And another advantage you will get that. So look here, this is another rectifier, right? This is a rectifier. If it is a rectifier, okay, then of course you will get a voltage like this, because lower side will be the lower means the negative cycle will be off, and it is a half wave rectifier like thing. So they have maybe they have considered only this one and this is the consider. Okay, so you will get this voltage, and by changing the T on and T off, your duty cycle will be changed. The output voltage will be your say VD. That will be K. If it is supply voltage is input, if it is input, so K. But if you change the K, then your VD will be changed. Output voltage here, or VD or V0, whatever. V0, this V0 will be changed. So what is the advantage we have got? The advantage here we got that we are getting a high frequency switching, and then we can use a high frequency transformer, not the line frequency transformer. Then the it will be light, not heavy, and also you look here, there are some. This is the L and this is the C. There are some filter because we want to clear out the ripple. So if we draw it, so you will have a AC voltage as well as the DC voltage. If you add these two voltages, this is your time. If you add this ripple voltage and also the DC, then you will get a voltage like this. So if you want to clear this ripple, then you will have to design the filter. And remember that if frequency is very high, then your filter size of the inductance and capacitance will be also less. So this is the another advantage you will get. if you use the power electronics. So they have, for your to understand, for your good understanding, they have simply simplified the circuit of the above circuit. Now they say, look here, it is they call it, this is your power processor. Are you familiar with the power processor? Hello, I have already told you. This is your power processor. This is the control signal. That this is your controller. I have given you the block diagram, right? So this is the load. From here, feedback signal, this is your refine, and from there will be input Vi. So this is your power processor. That is your power processor. We will process our power to meet the demand of our user. Now, what will be happening here? So this is the VD voltage. VD voltage is nothing but here, say, like this. So now if you turn on and off here, then you will get voltage, like output voltage will be the same shape, and with that one, if you figure out this one, then you will get a DC. I know that this is not very much clear to you, but in chapter 7 and 8 that has been given very clearly, but I am not going very deep. Rather than I am showing you this one. So, okay, here they mention here, like, look here, this is the AC signal. That is the ripple voltage that has been given here, and this is, if you add this one, can you see the equation number 1.1? Can you see equation number 1.1?
Yes, sir.
So it has a DC voltage as well as ripple voltage. So if so, the your V0I will be V0I will be like this. So if you just make it like ripple voltage will be, it has a AC like things, and always, and also this voltage will be DC voltage, fully DC, that has been like this, that has been shown in your figure. Show you where. Yeah. So this is your V0I. So V0I has a, look here, from here to here, this is your fully DC. And if you add the ripple, this one, if you add the ripple, this one, then it will be like this. Now, if we integrate this one, suppose this is the, like, if we want to integrate this one and then divide it by the time period t, then you will get the average value. I don't know whether your sir is doing it or not. So since it will be recorded, so I don't want to say how the seer will get the solution manual, but he will get it somehow. Okay. So those who needs, they should talk with the seer. But my suggestion is that don't look at the solution manual first. Try by yourself, and then that will be good for you, right? Okay. Now let us put 6B. They mentioned that No. Did I see the show you the chapter 1 or chapter 2? No, sorry. Sorry. This will be the two problems. Chapter either from chapter 1, 1.1 and 1.2. Look here, they have already referred the figure 1.1 and figure 1.2a. So you please try these two problems, okay? So please interact with me. Hello.
Okay, sir.
Yes, sir.
Okay, now I'm going a little faster now. Because, when a teacher is distracted, so it is very difficult to make you understand. So I miss your face-to-face class. Okay, there are some scope and applications. So what are the different types of application in the power electronics? So this is also given in any book of the power electronics. So we can divide in the four categories. One is the switch mode power supply, SMPS. So all your computers, all your say electronic devices which needs the DC voltage, they use this switching mode power supply. And also uninterrupted power supply, we call it UPS. Sometimes there is some IPS. So your sir will give you the idea what is IPS, what is UPS, and also at the end of the semester, I will take a review class. I will also introduce what is IPS, instant power supply, uninterrupted power supplies. Okay, we shall use the power electronics to do that, and people are using these things all over the world. Then this is the second thing is the energy conservation. Conservation. What is energy conservation? Any idea? Now look here. Nowadays people are using the tube light. Once upon a time people use magnetic blast. Ballast or blast? I don't know. Ballast. So there are inductive core, inductive choke. You did not see it. Choke. I don't know. What is that? Choke, we call it choke. There is a magnetic choke and it absorbs the energy, so it is being replaced by the electronic things, and then also it is being now replaced by LED, right? So what is the conservation energy means? What we want to use to conserve the energy, to reduce the loss, all these things. There is a very nice example that is given in this book. Let us have a look of this one. Here, can you see that?
Yes, sir.
Look here, you are using a motor, say AC motor, and here you have given the supply to that motor, and there is a pump here. So water is coming and you are pumping this one, and this is the throttling valve, and this valve does not have any control. So if you switch on the motor, so valve will be open and then water will go here. And even when your need is fulfilled, suppose you are trying to fill up a tank and you don't have any feedback whether the tank is filled up or not. So water will be overflow and then there will be loss of energy. But if you use the power electronic devices, then instead of use the fixed speed motor, you can have a variable speed of motor, and this is the power process. So that you have to process the power to change the frequency to have a changing frequency, and then you will control the flow of your water. So if you use the power electronics here, then you will have a controlled flow of water. Suppose you are trying to fill up a field irrigation. So you can change the rate of discharge of the water. So this is the one example of the energy conservation. So in the energy conservation, we can use the power electronics, and we have to use. And then this is the process control and factory automation. So have you visited the factory, anyone? So everything is now automated, and that is the contribution of the power electronic. One computer is controlling the microcontroller, and even you don't need too many operators. So in the industry, many thousands of variable motors are there, variable speed motors are there, and you can control these things by using this power electronic. And of course, in the transportation nowadays, this is very interesting. Now you already know the electric trains we have in India. In Bangladesh, we don't use. In other countries, they use the electric trains, and also buses. The bus, they use that in the overhead line. They make a line above the bus, and bus cannot move too far. They have a certain track, and they move that way. And also, you know that hybrid car. Are you familiar with the hybrid car?
Yes, sir.
So they use the say, well, what is that? The petrol and as well as the battery. This battery is very heavier, and sometimes when they are going from the overhill, like from the hill to down, the energy they store in the battery. And also in the regenerative braking, in the braking, we use the mechanical things, but nowadays they use the regenerative braking. So in the transportation side, we have a lot of use of the power electronics. And then the next one is the not for electrotechnical application. This is very, very popular application. So a lot of imitations you have seen, right? Have you seen a lot of imitation? So people are electroplating, and so you can also suppose in any nickel things, you can coat some nickel over any metal, or even in some other application, the welding, electroplating, induction heating. It is very, very popular nowadays. Have you seen the induction heating application at your home? Anyone?
Yes, sir.
There is some cooker, right? So by using the induction heating to make the heat, and this is also the application of the power electronics. And also the utility related application means that, so people don't never use the AC for the transmission system, because in the AC transmission system there are some corona effect, but it is transmission system is 1,000-mile transmission, not 20 or 50 kilometers. It is 1,000 kilometers. So you have the power plant. So you have a transformer, and then if you transmit it to the distribution end, then you have to do this one again, step down, and this is AC. So in some countries, in USA, also in German, so what they do, they make it AC to DC. So this one is now DC. And again, at the end, they make it DC to AC by using inverter. What is the advantage? Number one, they can use one single line, not three-phase line. Number two is that you can eliminate the corona effect. So you can use this AC to DC or DC to AC converter. That means the power electronics can do that. Okay. So these are the general way to look for the application. But here, look here, here they mentioned residential, refrigeration, freezer, space heating, air conditioning, cooking, lighting, commercial, industrial, all these things. And also if you look at the Harun Rashid books, they have given at least 500 applications mentioning particular. You want me to show it or you would see it? Hello? Hello? You can go to the Harun Rashid. Can you hear me?
Yes, sir.
We can hear you.
So you can go to the Harun Rashid book and look at that different type of applications. Okay. Now, generally we can, I have already given this introduction to you. So we have converter. One is the DC and another is the DC. AC-DC is that you have a converter like AC to DC, a constant magnitude, or you have a different magnitude. If you want to have a constant magnitude, you can use the diode rectifier. But if you want to use the adjustable magnitude, you can have some other things like DC. You can make AC to DC and then DC to all these things. So these are the things. You can just have a look, but this is not very much important for your course or in your exam. So there are, they mentioned the some of the power converters. I have already mentioned AC to DC, DC to AC, DC to DC, AC to AC. So we'll cover all these things, inshallah. Inshallah, next class we shall start the directly we shall start the switch. What will be the desirable characteristics of the switch of the like BJT, MOSFET, or say JFET? That we will discuss, and then we will discuss what will be the switching loss. How the switching loss is there in any power electronics devices. That is in our syllabus. We have to cover. And after that, we shall, inshallah, we shall start the diode circuits. Okay. So I am supposed to complete now because your class is from next class after Johor break, right? Your class today.
Yes, sir.
Yes,
I'm
sir.
very sorry that or because of the Zoom has the problem. So some people are suggesting me to go to the Google Meet. So the Google Meet problem is that I have already made a survey. It takes a lot of your data. Like those who are processing, if you don't have the Wi-Fi, you are processing some data. So lot of data is taken by Google Meet. Am I correct or not? And other thing is that I checked with the other students. They say that no, sir, this Zoom is better than the Google Meet. So what do you think? I should switch to Google Meet, or sometimes if Google is creating a problem like this, so you will tolerate that deviation. You have to tell me. If you keep silence, then how can I know that? Tell me.
Sir, would you prefer Meet instead of Google Zoom? Sorry.
Personally, I don't, because some of the people they are using the Google Meet, and they told that the mobile data, if you use the data, mobile data, so a lot of data will be taken in one class, and other classes I can switch if you want.
Sir,
But
then since no one has any issues they're talking about, let's just stick to Zoom since we have
yes,
we're
and
using
last,
Zoom. Let's use
yes, last say section C and section A, I did not have any problem, but today the problem is that maybe 50,000 users have already logged into the BDRAN Zoom. You know the BDRAN? Have you heard the name BDRAN?
Yes.
Yes or no? So the UGC is providing this BDRAN. Probably a lot of people are, so that their server may create a problem because my internet is very stable. And the speed is, you do know what is the speed of my upload and download? Can anyone guess?
50 Mbps.
62.
Oh my God.
So I have taken direct line from the internet provider in my local optical fiber line from their server room to my computer. There is a Wi-Fi router, and from that router I have the LAN line. So I am getting this much speed. So of course the lag, it is not lagging, right? Is it lagging my word? My
No, sir, it's not lagging. It has been very clear.
clear. The thing is that the problem of the Zoom. Anyway, hopefully, inshallah, it will work. And section C, A, B. Section A, I talk with them, and also C, and I am talking with you. You have to give me one word, because I cannot go very fast, because that I want to clear your basic. At the same time, I am trying to cover your syllabus. So maybe I need 2 or 3 extra classes with all 3 sections together, but not now after the Ramadan. Maybe at night, what I took for your other, like the first year I took, and also I took those 17 batch. So they gave me 2 or 3 extra classes, all 3 sections together. Will you give me this time? Hello.
Sure, sir. I don't think there
Sure,
is a
sir.
problem.
Yeah. Okay. So now I have already given you the book. So if you have time, just go through it, and I think you should go. Okay. Okay, then this is already looking very close to 1. Thank you very much for cooperation.
Assalamu
Actually, I
alaikum,
want
sir.
to, yeah, walaikum salam. Look here already, how many students? Already, this 34, 8 or 9 students have left. So should I take the attendance again to find out who has left? Sadia, are you here? Sadia from Mirpur.
She's
I mean,
here, sir. She's in speaking, I think. Yes, sir. She is here. I can confirm.
She's here.
Yes, sir.
Sadia, talk with me. She's sleeping. And I know that some of you, what you are doing, you are using 2 devices and connect this one from on behalf of your friends. Do you do that?
Sir, I would like to add something here. I have a phone and a laptop. Sir, what I did was connect from my mobile data from my phone and connect using my Wi-Fi from my laptop so that I don't miss anything. It happens sometimes that one device just the Wi-Fi fails or the mobile data fails.
I am doing the same thing.
Yes, sir, we have to do the same.
I have already made the hotspot to my these things, and I have two laptop actually, and I can see mine on another laptop. I can see who are, even I can see by the side view. I can see who are present, who are not present. So 3 devices I am using at a time. But so far, what I did, I'm not very much satisfied, because I have already taken 2 classes. I can give you the guarantee that maybe after the 1 classes, from the 4th classes, it will be very much interesting. Lot of mathematics will be there, and you will like it. Don't worry, okay?
Inshallah, sir.
Inshallah. Good. So now you can leave and take break, have your prayer and preparation to go for the next class. Thank you very much. Assalamu alaikum.
Assalamu alaikum, sir.
Assalamu alaikum.
Assalamu alaikum, sir.